Okay, our final concept here for this lesson is graphing logarithmic functions. So this should ring a bell. Our general parent function is just log base a of x, y equals log base a of x, where a is some number greater than 0. And the transformation equation is actually the same transformation equation we've used all along, where if there was a negative out in front, and we're going to assume that the parent function is y equals log base 2 of x for this one, hence the base of 2 right there. But it could be a base of 3 or base of anything. So remember, the negative out front is an x-axis reflection. Any value out front is a vertical stretch or shrink. Remember, it's a stretch when a is greater than 1, and it's a shrink when the absolute value of a is less than 1. The plus b, remember, it's left when it's positive, right when it's negative. And for our vertical shift c, up positive, down negative, the same as it always is for all of our other transformation equations. And remember the way that and just a quick reminder, the way that we handle this one is by multiplying our y values by whatever that coefficient is, by the coefficient. So by whatever that a value is. So if it's negative, you multiply by negative whatever. That's what you multiply by. Okay, so and a general graph of the parent function for a logarithmic, the way we come up with them is kind of similar to how we rewrite an exponential form, or we're going to have to do that because we can't really plug things in for x and know how it's going to work out. So our brains are just not used to working with logarithms that way. So the easiest way to do it is rewrite this in exponential form. So here's our base. Swoop our base over, make it 2 to the y power, now equals just x. Remember, the log goes away when we remove its base. And now I can plug things in for y rather than x. So we want to plug in for y the same thing as we did x, negative 1, 0, and 1. Negative 1, 0, and 1. And we're going to plug in those values. So we do 2 to the negative first. That's 1/2. So our first point is 1/2 negative 1. Then I'm going to do 2 to the 0. 2 to the 0 is 1. So my x value is 1. Then I finally do 2 to the first. That's 2. So those are my points. So I plot these points. X is 1/2 negative 1. So right about there. I've got 1, 0. It's right about there. And then 2, 1. Right about there. And then remember how our exponential functions had an asymptote. These have an asymptote as well, but rather than a horizontal asymptote, they have a vertical asymptote at x equals 0. Again, this makes them the inverse of our function. So if you see the shape here, follows the asymptote and continues going up and to the right, but not very steeply, somewhat flat. But it is going up and to the right, just not at a very high rate. And there we go. And that's our general function that's the function of y equals log base 2 of x. Log base 3 of x would not look too much different. They all have this general same shape with a vertical asymptote at x equals 0. Okay, so let's go through the steps for graphing logarithmic functions. But before we start with logarithmic, let's review what the steps were for exponential functions. So remember, for this example, we want to start by IDing the parent graph. So for this one, the parent graph was y equals 2 to the x. Remember, you strip away the a term, the b term, and the c term, and you just look at what's left after that. All right, now we ID our transformations. So our transformations, we've got the 3. That's a vertical stretch by 3. And the way we do that is we multiply our y values by 3. We'll multiply y values by 3. That's how we do that one. The green underlined 1 is a horizontal shift, left 1. And then the underlined blue here is a vertical shift down 2. So those are our transformations of this function. And now we plot our points of the parent function. So we plot our points of the parent function using the points x equals -1, 0, and 1. So make an xy chart using the points -1, 0, and 1. Remembering that we have a horizontal asymptote. Remembering that we have a horizontal asymptote right there for our parent function at y equals 0. So we plug in our points. So we've got 2 to the -1, that's 1/2. 2 to the 0, that's 1. And 2 to the 1, that's 2. So here are our 3 points. So -1, 1/2, 0, 1, and 1, 2. So that's the points of our parent function right there. Now we have to apply the transformations to our plotted points, making sure we do the vertical shift last. So here we go. Let's apply these transformations. Start by multiplying our y values by 3. So this point's at y equals 2, so it's going to go to y equals 6. This one's at 1, so it's going to go to 3, because 1 times 3 is 3. And this one's 1/2, it's going to go to 3/2, which is 1 1/2. All right, so there's multiplying by 3. And now move everything left 1 and down 2. So let's go ahead and move our asymptote down 2, because we know that's where our asymptote is going to end up, because moving it left and right doesn't do anything, but moving it up and down does. So we'll go down 2 for the asymptote. And let's put our final, we're going to go left 1 and then down 2 for each one of these. So left 1 down 2, left 1 down 1, 2, left 1 down 1, 2. So those black points are our final, is our final answer. So we just pass through each of those and follow our asymptote. And that right there is how we graph an exponential function. Now, for graphing a logarithmic function, it's very similar, extremely similar actually. So we start by IDing the parent graph. Well, remember our parent graph is what's there when we strip away the transformations. Well, the transformations are the 3, the +1, and the -2. So what's left when we strip away those is just y equals log base 2 of x. So that's our parent function. We have the exact same transformations over here that we do over here. We have a vertical stretch by 3. We have a horizontal shift left 1 and a vertical shift down 2. So I can just bring these over here. Bring those over here. So those are our transformations. All right, so our vertical stretch by 3 from this 3, our horizontal shift left 1, and our vertical shift down 2, same exact transformations. But now we have to convert our parent graph to exponential form. So this is where it starts to get a little different. Because we're not already in exponential form, we can't just go ahead and plug in. We want to plug in when we're in exponential form, not logarithmic form. So we're going to take our parent graph, our log base 2 of x, and we're going to rewrite it in exponential form. And remember the way that we do that is we identify our base, which was 2, swoop it to the other side, and then rewrite in exponential form. So we're going to have 2 raised to the y power equals x. So there we are, 2 to the y power equals x. And now, instead of plugging in x values like we did over here, we're still plugging in for the exponent, but the exponent's a y now. So we're going to plug in for the y values of -1, 0, and 1. So make our t-chart, x and y. And we know we're going to plug in y values of -1, 0, and 1. So we've got 2 to the negative first. That's still 1/2. So x is 1/2, y is -1. 2 to the 0 is 1. So x is 1 and y is 0. And 2 to the first is 2. X is 2, y is 1. Notice they just basically switched. The reason why they switched is because y was in our exponent, not x. All right, so now we can plot these points, remembering that every exponential starts with a vertical asymptote at x equals 0. So vertical asymptote at x equals 0. And now we can start to plot our points. So we have the points 1/2, -1. So 1/2, -1. Let me change colors here. We'll start with purple again. So 1/2, -1. There's our first point. Then we've got the point 1, 0, and the point 2, 1. So it would look like this nice curve right here. So, but we need to apply our transformations now, making sure the vertical shift is applied last. So we're applying our vertical shift last. So we're going to start with our vertical stretch. So we're multiplying y values by 3. So this one was -1/2. It's going to go down to -3/2. So -1. Whoops. No, that's right. Sorry. Our y value was -1, so it's going to go down to -3. X value still stays at 1/2. So 1/2, -3 down here. This one at 0, 0 times 3 is still 0, so this one's just going to stay right there. And then 1 goes up to 3, because 1 times 3 is 3. So those are our 3 points. It's going to be a more stretched out curve. And then we got to move everything left 1 and then down 2. So let's go ahead and move our asymptote first. So asymptote moves left 1. So left 1 for our asymptote, because moving it up or down won't change anything. And now we move all the green points, left 1 and down 2. So left 1, here we go. Left 1, down 2. Left 1, down 2. Left 1, down 2. And those points right there are the points of our logarithmic curve. And we are finished. Okay, so time to check your understanding. So I want you to pause the video, attempt the problem below, unpause when you're ready to check your answer. Okay, so we're graphing the logarithmic function. Use the steps from the previous slide. If you haven't already written them down, you probably should. So here we go. So we're starting by identifying our parent function. Parent function first. So our parent function is just y equals log base 3 of x. And we knew that because if we strip away all of the transformations, the a value out front, the +4 inside, and the -1 outside, all that's left is log base 3 of x. So that's our parent function. All right, let's identify our transformations now. Transformations. All right, so we've got two transformations with the negative and the 2. Remember, we have a vertical reflection, also called an x-axis reflection. That's from the fact that it's negative. We also have a vertical stretch by 3. Vertical stretch by 3. That encompasses all the red. And remember, we handle all this by multiplying our y values by -2. That's how we do all of this. All right, then the green one, that's our horizontal shift. And that would be left 4. And then we have finally our vertical shift. And that's negative, so it's down 1. Remember, horizontal is opposite what you'd think. Plus is left, minus is right. Okay, so now our next step. Hopefully you can remember what our next step is. Try to think about it. So our next step was, this is not ready to plug into yet. So we have to take this and rewrite it in exponential form. So let's do that. Identify our base, swoop it on over, write an exponential expression with a base of 3 over here. So we're going to have 3 to the y power on the left side of our equation equals x on the right side. And now, to plot the points of that parent function, I need to make an xy chart. using the y values rather than x's. So since the y is in the exponent, that's the one I'm going to plug in from 0, -1, and 1. So I'm going to plug these in. Got 3 to the negative first. That would be 1/3. So x value of 1/3, y value -1. That's our first point. Second point, 3 to the 0. That would be 1. Third point, 3 to the first. That would be 3. So we have these 3 points, 1/3, -1, 1, 0, and 3, 1. Always remember to start with our vertical asymptote at x equals 0, which it always starts at for any and every logarithmic function that we're graphing. And now we plot these points. So we're at 1/3, -1. I'll make these a different color so they stand out a little bit. So we've got 1/3, -1. So 1/3, -1 is kind of close to that asymptote there. Then we're at 1, 0. And then we're at 3, 1. 3, 1. And it would look like this for our parent function. Get mighty close to this asymptote and head almost vertically down and stretch out to the right. But we're not graphing the parent, we're graphing our transform function. So let's go ahead and start applying our transformations, which is our final step. So apply our transformations, making sure we end with our vertical shift. So we start by applying our vertical reflection and vertical stretch by multiplying our y values by -2. So y value here is -1, so we multiply by -2, it goes up here to 2. So flip it upside down here, which makes sense since we had our x-axis reflection. All right, 0 times -2 is still just 0, so this point doesn't move right there. And then our point at +1 gets multiplied by -2 and goes down here to -2. So we have an upside down logarithmic function. And now we apply our horizontal shift and vertical shift. So we got to move everything left 4 and down 1. Remember, our asymptote gets affected by leftward shifts. So we're going to make this go left 4. So we're ready to move those red points left 4. All right, and then let's move our actual points. We'll make the final product here black again. Now let's make it green just so it stands out a little better. So this point's at 1/3, so it goes left 4 and then down 1. So left 1, 2, 3, 4, down 1. So right there. Okay, left, so this point is right at 1, 0. So left 1, 2, 3, 4, down 1. And left 1, 2, 3, 4, down 1. And right here is our final answer for our graph. And there we have it, passing through those 3 points, vertical asymptote at x equals -4. And that concludes the 3.3a podcast. Make sure you watch 3.3b as well.